Hi class, hope you're doing well. This week we're talking about how to describe your data, and first of all, let's try practicing how to do that in Excel. In this lecture, we'll cover three main topics. First of all, we'll review some basic statistical concepts. And I call that a review because you've already taken statistics before, and so these concepts are most likely going to be familiar to you. And then we're going to go over functions in Excel and how to write them. And then we'll conclude by doing an activity together where we'll both generate descriptive statistics using Excel. So let's get started. So descriptive statistics allow you to describe variables. Phew, no surprise there, right? Now there are two main types of descriptive statistics. One is central tendency. And so measures of central tendency allow you to say sort of the most central defining point in your data. Now the measures of variability, on the other hand, allow you to describe how spread out the data are. And which specific measures you use of these depends on the variable's level of measurement. So you might recall learning about that in your prior statistics class. So level of measurement refers to the type of information that's in your variable. And there are four different levels, and they're organized from lowest to highest. So let's start with the lowest level, which is the nominal level. At the nominal level, information that's contained within the variable is categorical, so there are distinct categories, for example, type of fruit. The next level of measurement is the ordinal level, and that refers to rank-ordered information. And so, for example, what place you might have earned in a race. That's rank-ordered. The next level is the interval level, and so at that level, the variable is considered continuous, and there is the same distance between each point that's possible within that variable. So for example, temperature. So for example, 1 degree Celsius to 2 degrees Celsius, the difference between those two are the same as from 4 degrees Celsius to 5 degrees Celsius and so on. And finally, the highest level of measurement is the ratio level. At ratio level, once again, the variable is continuous, but it has a meaningful absolute zero. So for example, weight, if it's zero, then there's none of it. And so that's a meaningful absolute zero. And so that's the ratio level. And so again, these four levels are organized from lowest to highest. And what's something that might be good to know is that at interval and ratio level, generally the variable is considered continuous for purposes of analysis. At nominal level, data are considered categorical. Now we'll talk a lot about this later on, but ordinal can also swing both ways depending on the nature of data, but oftentimes it's treated as categorical. And it's important to know at what level your variable is so that you can figure out what type of measures of central tendency and variability you can use to describe your data. So let's talk about measures of central tendency first. And so there are three types. First is the mode, so the most frequently occurring score. Then there's the median, which is the middlemost score in a distribution. So if you line up all the data points from lowest to highest, median is a smack middle. And then there's the mean, which you know to be the average score. And which measure you can use, once again, depends on the type of variable that you have. And so for interval and ratio levels, you can use any of these three. But for ordinal, you can't use the mean. You can use the mode and the median. And then for nominal variables, you can only use the mode, so the most frequent category. Now, something that I'd encourage you to keep in mind is that you'd want to also consider which measure best describes your data. And so, for example, if you have taken economics, you might know this, but for income, you might be tempted to use the mean as the average to describe the central tendency, but oftentimes the preferred measure of central tendency for income is actually the median, because income is the kind of variable where you might have a lot of outliers and it's quite spread out in a very uneven way. And so mean can be rather deceptive because it's swayed greatly by outliers, whereas the median can give you a sense of the midpoint without being swayed by the outliers. And so that's one example of where you'd want to choose a central tendency measure based on the type of data, the nature of data that you have, and that's your decision. So in other words, approach thoughtfully. Let's now talk about measures of variability, so how spread out the data are. Now these measures describe how much the scores in a variable differ from either one another or from a measure of central tendency. Examples might include the range, interquartile range, variance, and standard deviation. Now once again, you'd want to think about what level of measurement your variable would be at, and then you can figure out which measures you can use. And so for nominal variables, you really can't use any measure of variability, just wouldn't make any sense. But for ordinal, you can use the range and the IQR, interquartile range, and then for interval and ratio level, you can use all that are available. And once again, you'd want to think about which measure best describes your data. Alright, so now that we've reviewed some useful statistical concepts, let's talk about functions in Excel. So what are they? They refer to Excel's built-in calculator program, and you have quite a few options. And in general, the format looks something like this, where you would type in equal and then the function name, and then in parentheses a particular argument. And so what goes in the parentheses would be specified by the type of function that you have, and there are no spaces, you just write them all out like that. Oftentimes in our class you will see this format where you would have the equal sign, the function name, and then you would contain the cell addresses that you'd want Excel to operate on within those parentheses. And there are a few different ways you could insert functions in Excel. The most straightforward way, if you know what function you want to use, is to type it in, if you actually know its name. So you've seen me do that in the previous lecture. You could also go and click on the Insert Function button to the left of the formula bar, so it looks kind of like that, FX. And then finally, another option is to go to the Formulas tab and then click on the button that says Insert Function to the left-hand side. And so if you were looking at Excel, then here are the three different types. So example 1 is that you type it into the cell directly. The second option is to click on the Insert Function button that's to the left of the formula bar right there. And then finally, if you go to the Formulas tab, then you can go and click on Insert Function. And all three ways are good ways to put in your functions. Now let's talk about how to refer to cells as you write your functions. So you already know how to use these two addresses, the relative and the absolute. Now let's talk about what are called reference operators. And so this is a way to refer to multiple cells that may be in different locations. And there are two types. There's range reference and then the union reference. The range reference refers to all contiguous cells within a reference, and it consists of two cell addresses separated by a colon. And so here's an example where if you have a reference A1 colon A3, that means that would include cells A1, A2, and A3, so all contiguous cells contained within that reference. Let's say that you had a reference that was from A1 colon C3, in which case you would have A1, A2, A3, B1, B2, B3, and then C1, C2, C3. Now that would make more sense if I showed it to you in Excel, so let me show you what I mean. And so let's say that I wanted to take a sum of the first 3 rows and 3 columns. So that would be that reference that I just mentioned. And so here's the A1, and then you can just left click and drag to get to A1 colon C3. And as you can see, now Excel is including all the cells that are contained between A1 and C3. So that's what the range reference looks like. Now let's talk about the union reference. So the union reference refers to non-contiguous cells, and they look like cell addresses that are separated by comma. So you can literally type in your commas as you're clicking through or typing in the cell addresses. So the reference A1, B3, C2, that particular reference refers only to those 3 cells. And so again, you can just type in your comma and let Excel know that these are the only specific cells I want you to include. Now here's a good hint. So let's say that you're writing your functions and you want to check your reference operators to make sure that they're selecting the correct cells. What you can do is click inside the formula bar to have Excel highlight the cells that you included. So for example, coming back to the spreadsheet that you just saw, let's say that you wanted to just click on the formula bar, then Excel automatically highlights what you've included in your cell references. And so that's going to be a handy tool if you need to check your work. So now you know some basics about using functions in Excel. Now let's apply them and see if we can generate descriptive statistics in Excel together. To get this work started, go ahead and download and save the sample grade data Excel spreadsheet that's been given to you if you haven't done so already. There's a link provided in the lesson for you to download this file, and then you can open that file in Excel, and I'd encourage you to save that file as a different name. So for example, Excel Descriptive Statistics Activity. That way, if you come back to the reference notebook, for example, you'll know what the Excel workbook is for. And I've suggested the location within your reference notebook that you can go to, which is inside the Excel folder. And then there's a folder called Descriptive Statistics, Functions, and Formulas. So that's a good place to save your file. Once you've saved your file, go ahead and open it up in Excel and take a look. So this is a sample grade data file. If you look inside, you'd find 3 variables: scores for midterm 1, midterm 2, and final exam. And each row represents one case or one individual. In this case, it would be a student taking the exam. And that's a very common way to organize data sets, which is that each row represents an individual, and then variables that measured something about that individual are listed in columns. And so for the most part, the data sets you encounter in this course and beyond will have that organization. Now if you look at the right-hand side of your spreadsheet, columns E to H, you'll see a bunch of words and you might wonder why they're there. This is a very common way to organize information. And so Excel might be often used to organize information into tables, and so you would type out variable names that you want to calculate for rows and columns. And so here you have an example where I'd want to calculate a whole bunch of statistics, and that's what we're going to do today under column E. So I listed down all the things that I want, and then for columns F through H, I made space where I could write down the corresponding scores for midterm 1, 2, and final exam. And so the calculated data would go inside the table right here. And so this is very common to create your own little table within Excel to organize your data. So let's dive right in and find the mode together. And so let's find the mode for midterm 1, which is the first item. So if you go to cell F2, this is where you would input the mode for midterm 1. And so periodically, I would encourage you to stop the video and do the work that's outlined for you here, and then come back, and so you can compare notes with my answers. And so first of all, I've listed the steps for looking up the function for mode. So if you go to the Formula tab and then click on Insert Function, you can search for it. So if you can, I'd invite you to follow along, perhaps by having the window with the video in one part of your screen and then maybe having Excel in the other part of the screen. Alternatively, you can also pause the video periodically and you can replicate the steps we just covered. And so in this case, let's go to Formulas tab and then click on Insert Function. And then you can just search for a function by typing in mode and hitting go. And there it is. Excel found the function for mode for you, and so you can click on OK to insert it. Now you now have to tell Excel what cells need to go into that calculation. In this case, we actually have 100 students, and so that goes down to row 101 because the first row in our data set is taken up by the name of the exam. And so you can just type in A2 colon A101 to let Excel know that you want to calculate mode for midterm 1, and then click on OK and you get that information. So, did you get the mode of 65 for midterm 1? Sure hope so. Now let's find the median together. So as you know, median is the middlemost score in the distribution, and we'll put that down in F3. And so this is another way of looking up that function. You can click on that FX button to the left of the formula bar. And then this time, here's another way to look for a function. You can go to select the category drop-down and then choose statistical. And then they'll give you a list of functions and you can find the median in that list. So to demonstrate, you can click on the Insert Function button and it pulls up the same window as you've seen before. This time you'd go to the Select the Category drop-down menu and choose Statistical. And if you do, you get a nice long list of different statistical functions that you could use. And we're looking for median. And so here it is. So there's the median, so you can hit OK. And once again, Excel is asking you what cells go in. Now you can type it in But if you go to little icon right here, it allows you to insert the cells by clicking and dragging. And so I can click on A2 and holding my left mouse button down, just go and scroll all the way down to the last student and then let it go. And then you can press enter, and that's inserted the cell reference for you, and you can click on OK. And there you have it. Now go ahead and pause this video and give it a try yourself. Welcome back! How was your median? Mine was 73.5. Hope our numbers match up. Now let's go ahead and calculate the mean next. So go ahead and go to cell F4, where the mean will go, and type in equals average and then the cell reference. So you've seen me do this before in a prior lecture, but you can just type in the function if you know its name. And this example is just to show you that you can type everything in lowercase, and that's perfectly fine too. You don't have to do all caps. And so you can press enter to get the number. So go ahead, pause this video, and give it a try. Hope you got this mean too. So now let's move on to measures of variability. And so I'd like you to calculate these 4 measures, and I'm going to show you how to go about it in Excel, and then I'd like you to give it a try before you check the answers against my slides, okay? And so I'll let you know when to pause and give it a try yourself. So let's talk about range. And so range is the highest score minus the lowest score. So what you need to calculate is the maximum score and the minimum score and take the difference. Now in Excel there's no range function, but you can calculate the maximum and the minimum values, and that will help you to obtain the range. So here are the functions for maximum and minimum values. Go ahead and input these in applicable cells and make those calculations. So you can pause this video now. Alright, welcome back. So the correct functions will look like these. I bet that you got them in your spreadsheet now. Now you can go ahead and now calculate the difference where the range goes. So that will be maximum minus the minimum. Go ahead and pause this video and calculate the range. Alright, welcome back. So, hope you got the range of 50. That is what I got for midterm 1. Moving on to the IQR. So the range itself is very susceptible to extreme scores, so you can imagine that if you have a very high outlier, then the range is going to expand to accommodate that outlier. Now to remedy this, statisticians may use the IQR, which uses the middle 50% of the scores. So this is the range for middle 50%, and you can calculate that by taking 75th percentile score and subtracting 25th percentile score to get the range for the middle half. And so that essentially means 3rd quartile minus 1st quartile scores. Now once again, Excel does not have an IQR function, but it can calculate the IQR based on your quartiles. And so 3rd quartile and 1st quartile are both things that you can calculate in Excel. So first of all, let's go for the 3rd quartile, which is the 75th percentile. So you can go to cell F8, where this information should go, and then go ahead and search for the quartile function. And once you do that, then you get the function arguments window, which will ask you for additional information. And so in the array field, you'd want to put in the data range, which is the A2 colon A101. And then for the quart field, it's asking you which quartile do you want. We want the 3rd quartile, so you want to type in 3 and then hit OK to get the 3rd quartile. And so go ahead and pause this video now and give that a try to get the 3rd quartile. Welcome back. Now we can now calculate the 1st quartile. So you want to go to cell F9 to input that information. Now if you go to the Formulas tab, you can actually click on the recently used button to get the quartile function now that you've run it. And so you can do the same thing as before, but this time enter 1 for quart to indicate that you want the 1st quartile, and click on OK. And so go ahead and pause this video and calculate the 1st quartile. Okay. Now, drum roll please, the IQR itself, very exciting. So if you go to F10, you can enter the formula for 75th percentile minus the 25th percentile. So take the difference. And so you'd want to enter the formula that looks something like this. Go ahead and pause the video to give it a try and get your IQR. Alright, did you get 27.5? That should be the IQR for midterm 1. Alright, watch you go, rock and roll on to variance. So variance is determined as this equation right here, so you can make these calculations. Let me simplify that. So if you take each score and subtract the mean from it, square that difference, and do that for every single score and sum it all up. So there's the summation sign, sigma, and divide that sum by n-1, then you will get the variance. So in other words, what you see in the numerator is called sum of squares. So essentially you take the deviation from the mean for each score, square that, and then sum it all up. So and then you get the sum of squares. Pretty descriptive name, isn't it? Divide by n-1, you would get the sample variance. Now, what do I mean by that? So if you look at the denominator, you have n-1 to account for the fact that you don't have all the scores possible in the entire population of, in this case, students that might be taking that exam. So if I happen to have all the students who would ever take that exam in my data set, you would actually use the population variance because you'd have the data for the entire population. So if you wanted to calculate the variance for the population, you would use the denominator of n, not n-1, which makes an adjustment for the fact that you have a sample that's estimated the population variance. And so those are the two forms of variance. There's a sample variance for if you have just a sample of the entire population with you, and then there's a population variance in case you have everybody in that population within your data set. Alright, so taking the sample variance, you can now calculate this in Excel. So that's pretty cool, isn't it? So now you can subtract the mean from each score. So the mean for midterm 1 is in cell F4, so you can create an absolute address for that cell, and so subtract the mean from each score, and then square that value. And so you can see the caret sign to represent exponential. And so square that value. And so you can do that for each score. Then you can sum all of those squared values to obtain the sum of squares, and then divide that by n-1. So that's really exciting that you can do this by hand now in Excel. So you ready? Woohoo! Let's do this! Get psyched! Time to calculate the variance. Never an exciting time such as this. Just kidding, class. I'm just kidding you. You'd hope that Excel by now will have come up with an easier way to calculate variance. With that said though, you gotta admit it's pretty cool that you can calculate all that by hand now in Excel. Now all kidding aside, I hope I woke up some of you with that. Now, let's calculate variance using Excel's function. That would be exciting, yes? So let's go to cell F11, and now this time go ahead and search for a variance function. So you can use the search term variance. Now perhaps you like to go and click on Insert Function button to the left of the formula bar, or perhaps you like to go to the Formulas tab and then click on that trusty Insert Function button to the left. So go ahead and pause this video and look for a variance function. Welcome back. So if you're looking for the variance function, then you would have had this particular pop-up come up, and you've seen all these different options for how to calculate variance. And so let me help you choose. And so for sample variance, go ahead and use var.s. And then for population variance, go ahead and use var.p. And so go ahead, pause this video and calculate the sample and the population variance. So hopefully your functions looked something like this, which will have resulted in these figures. So I've rounded for you to the 100th place, but originally you might have gotten about 4 decimal places in your cell. And so here are the two variances. And what's left here for us to fill out is the standard deviation. Standard deviation is the square root of the variance. So you just take a square root of the variance, And it's often used to make the spread of data more understandable. Why is that? Well, first of all, standard deviation is in the original units of measurement. So for variance, you squared a bunch of things and then manipulated that figure. But for standard deviation, you take the square root of that, and so you come back down to the original unit of measurement. And so if you think about it, in our example, exam scores have ranged from 50 to 100. If I gave you a variance of 238, what does that really mean? That's really hard to understand, isn't it? In contrast, standard deviation is in original units, and so now you can describe the spread of data in terms of the actual exam scores themselves. And so once we have the standard deviation and know how many points they are, then you can talk about the spread of data from the mean using, for example, what you see here is normal distribution. And so what percentage of students fall within particular bands of scores from the mean. So let's find the standard deviation. And so go ahead and search for the standard deviation function. You can pause the video to do so now. Now you search for standard deviation, and then once again you get multiple options. And so very much like what you saw for variance, now you can use stdev.s, so S for sample standard deviation, and then stdev.p for population standard deviation. And so go ahead and use these standard deviation functions to calculate those two numbers. You can go ahead and pause this video to do so now. Welcome back. Did you have these functions, which led to these two numbers? Once again, I have rounded the numbers to the 100th place, which you will do often later on in the course, just to show you examples. But hopefully you got these two numbers. So now that you've calculated the standard deviation, you can now talk about the distribution of scores in a way that readily makes sense. So coming back to the trusty old diagram of the normal distribution, and if you take a look at, for example, this figure, then you can translate that to your data and talk about how 68.3% of your students scored within 15.43 points of the mean. And so now you can talk about how spread out the data are in the original units of measurement, in this case exam scores. So that's pretty nifty that you can talk about your distribution of scores that way. So now go ahead and calculate all the descriptive statistics that we just went over for midterm 2 and final exam. And you will have a complete table of those descriptive statistics in your Excel spreadsheet. Now here's a hint though. You may wish to review your notes on how to copy and paste or drag and thereby transfer formulas. So we've gone over this before. You may wish to review those instead of filling out each cell one by one. So go ahead and pause this video now to finish that work. Welcome back! And so to wrap up, in this lecture, you've reviewed some basic and important statistical concepts and learned to generate descriptive statistics in Excel to describe your data. And so that's really neat that you can do that now. Very proud of you. It's been really nice spending time with you today. Take good care and have a happy day. See you next time.